All right, they want us to find y prime for this problem. So this requires implicit differentiation. And there's a couple different ways you can do it. So I'm going to go with my gut, and I'm going to multiply this over because I'd rather not use the quotient rule if I can help it. I'd much rather have everything written in a linear fashion. And then I'm going to go ahead and distribute that in even. So this is 12xy minus 12y cubed equals x plus y squared. In fact, I'm going to go ahead and move all the y's over to the right side. So x equals 12xy minus 12y cubed minus y squared. And the reason I'm doing that is because I know all of these are going to end up with a y prime, or derivative of y. And so I want them all to be on the same side. Yeah. And I'm going to have to move some other stuff over as well. So let's do our implicit differentiation. So the derivative with respect to x is what I'm doing. The derivative with respect to x, that's how I like to write it, to help me understand. So the derivative with respect to x of x is just 1. The derivative with respect to x of 12xy is going to be, I'll keep the 12 with the x. I'm doing the product rule. 12 times y plus 12x times y prime. Got that? Minus the derivative of this with respect to x. Well, there are no x's, so I have to do the chain rule. So bring the 3 down. So that's 36y squared times the derivative of whatever y is on the inside. And then same with this. Bring the 2 down times y to the first, which is just y, times y, the derivative of y. Okay? Now, I don't need this over here because there's no derivative of y. So I'm going to move that over to the left. 1 minus 12y equals, and then at the same time I'm going to factor out a y, the derivative of y from all of that, and I'll have 12x minus 36y squared minus 2y.
Okay.
Got it?
Yeah.
And then now the answer is just divide this side by this thing. So I'll write that up there. Y, the derivative of y equals 1 minus 12y all over 12x minus 36y squared minus 2y. And you see, can I cancel anything out? Not really. These 12s can't cancel, obviously, because they're not factors of the entire top and bottom.
Yeah.
So there's your answer.